On October 30th, 2018, NASA announced the end of the Kepler Space Telescope's 9-year exoplanet hunting mission, after discovering more than 2,600 new worlds, including Earth-sized planets, in their star's habitable zones. Welcome back to Launchpad. I'm Christian Reddy, your friendly neighborhood astronomer. The Kepler Space Telescope was launched in 2009 after astronomers spent the previous 17 years detecting planets around other stars. These extrasolar planets, or exoplanets, were unlike anything that we've ever seen here in our solar system before. These were large, gigantic planets that were orbiting so close to their host stars that they would complete one path around their star every several days. In fact, some of these planets had orbital periods measuring in just hours. Astronomers wanted to know if there were any Earth-sized planets orbiting at a safer distance from their host stars, where the temperatures would be warm enough to allow water to condense on their surfaces, but not so cold that it would just freeze out entirely. In other words, could there be Earth-sized planets orbiting in stars' habitable zones? Now, just because a planet is in a star's habitable zone does not guarantee that the planet automatically has life on it. All it can really tell us is that the planet is just at a distance where water could be stable on its surface. And since water is an essential ingredient for life, we call it the habitable zone. Kepler was equipped with a 1.4-meter mirror and a 95 megapixel camera, the largest camera ever flown in space by that time. By placing a telescope in space, Kepler would be able to detect a drop-off in a star's light of just 1 part per 10,000. That's like having 10,000 light bulbs and turning one of them off. This kind of sensitivity was unprecedented, but would allow astronomers to detect Earth-sized planets transiting in front of their host stars. 3 sequential transits would be confirmation that this was due to a planet orbiting its host star. The timing between the transits would tell us how long the planet took to orbit the star, which in turn tells us the planet's distance from the star. The shorter the period, the closer the planet. The longer the period, the more distant the planet. But astronomers could also learn something else from these transits. By examining exactly how much light was subtracted from the star, astronomers could infer the planet's radius. Smaller planets subtract less light from their host stars, while larger planets subtract more light. Kepler would spend the first 4 years of its mission staring at a single region of the sky in the constellation Cygnus. This part of the sky was selected because it lies along the plane of our Milky Way galaxy, providing Kepler with a rich field of 150,000 stars to monitor. Almost immediately after it got to work, Kepler started to detect one exoplanet after another. By 2011, Kepler was on a roll. It detected the first ever large rocky planet surrounding the star Kepler-10. This planet, called Kepler-10b, orbits so close to its star that its daytime side is hot enough to boil iron. This world would be a lava planet, its atmosphere long stripped away by the wind from its star. The discovery of Kepler-16b revealed the first planet ever to orbit a binary star system straight out of Star Wars. Kepler-20e and 20f became the first 2 Earth-sized planets to be found orbiting a Sun-like star. And Kepler-22b became the first planet detected in a star's habitable zone. Kepler would continue to make one amazing discovery after another until May of 2013, when the second of its 4 reaction wheels failed. But with the failure of its second reaction wheel, Kepler no longer could maintain its stable pointing. Kepler's primary mission came to an end. But Kepler's operations team knew that they had an otherwise perfectly healthy spacecraft. All they needed was a way to point it and keep that pointing stable long enough to do science operations. The mission operations team figured out that if they could orient Kepler just right, sunlight pressure could be used to help keep the spacecraft stable. This would give Kepler a new lease on life, and the second light mission of Kepler, or K2, was born. But this new orientation also meant that Kepler would have to point away from the sun once every 80 days in order to prevent sunlight from entering the telescope. Even with these new restrictions, Kepler delivered an incredible amount of new science. It monitored variable stars, brown dwarfs, and red supergiants just as they went supernova. But in order for Kepler to change its pointing every 80 days, it had to make use of its thrusters, which in turn depleted its fuel supply. By October 2018, Kepler had literally run out of gas, and NASA announced its retirement. In its 9.5 years in space, Kepler had monitored over 530,000 stars, detecting 61 new supernovae, and, oh yeah, over 2,600 confirmed exoplanets. That's about 70% of all of the exoplanets that have been discovered to date. But Kepler's contribution will continue to grow even after its mission ends. That's because it found an additional 2,500 candidate exoplanets, most of which will certainly be confirmed by follow-up studies. But Kepler leaves behind something far more important than just a huge stack of planets to study. It tells us that planetary systems are common, and in fact there are more planets than there are stars. It also showed us that planets come in a wide range of sizes, some smaller than Mars, others larger than Jupiter. But the most common sized planet fits somewhere between the sizes of Earth and Neptune. In other words, the most common type of planet is a super-Earth, something that we don't seem to have here in our solar system. And it also showed us that our solar system is actually kind of weird. Most of the planetary systems that Kepler found are very compact, with planets clustered so close to their stars that they would fit well inside the orbit of Mercury. Whereas our solar system seems to be spread out. And this tells us something about the nature of how our own solar system formed. And Kepler did show that Earth-like planets can and do orbit in their stars' habitable zones. It's just that the frequency of those planets is a bit lower than we would have hoped, hovering around between 12 to 20%. But now that we know that planetary systems are common, the Transiting Exoplanet Survey satellite is looking for planets around nearby brighter stars. This will make it a lot easier for telescopes like the James Webb Space Telescope and the Extremely Large Telescope to follow up and study those planets in greater detail. And so, we say so long, Kepler, and thanks for all the exoplanets. So what do you think of the Kepler mission? Did it make a discovery that you were particularly excited about? Let me know in the comments below and I'll be sure to check them out. And if you have watched this video all the way to the end, then chances are you probably are digging what we're talking about here. So I'd like to invite you to subscribe, and when you do that, make sure you ring that notification bell so that you don't miss out on any new videos. Until next time, I'm Christian Reddy. Keep watching the skies.